Okay, in this lesson, we're going to use our trig ratios, or SOHCAHTOA, to find the side lengths. So the sine, cosine, and tangent ratios are used to find the measurement of side lengths and angles in a triangle. This lesson will focus on the lengths. When you encounter a problem where you have the length of one side and at least one of the acute angles in a right triangle, it is possible to use a trigonometric ratio to find the length of the third side. Note, you cannot use that right angle, the square angle, at all. Okay, how do I use my calculator? First things you have to make sure is you have to make sure that your calculator is set to degrees. If you look at a scientific calculator, you'll see right here there's a degree function, radians function, and a gradients function. So you certainly want it set to degrees, or else you won't get the values that you expect. So step one, label the sides of your triangle relative to the angle. So we can see right here that our reference angle is 41 degrees. That'll make this the opposite side, we'll call x, and this the hypotenuse, and this the adjacent. Now, we're asked to figure this out, this particular side, which is the opposite. So, we have to determine which trig ratio to use, sine, cosine, or tangent. Well, we're asked to find the opposite, and we're given the hypotenuse. So we look down here at our trig ratios and find a trig ratio that deals with opposite and hypotenuse, and that just happens to be the sine ratio. So that's the one we're going to choose. So we'll set it up. We can state that the sine of 41 equals opposite over hypotenuse. So in this specific case, we can say the sine of 41 equals x, which is the opposite side we're trying to find the value of, over 15. So here's our setup here. Sine 41 equals x over 15. We cross multiply and just use standard algebra to figure out the value of x now. So we can restate that as x equals 15 times sine 41. Using our calculator, we figure out what the value of sine 41 is. So I'll just bring up the calculator here. So I type in 41, and I go to trigonometry and choose sine, and I get this value right here, 6560. So we can take this 656 value, multiply it by 15, and this gives us 9.84, which we can round off to 9.8. So we can say that our side x is 9.8 centimeters in length. In this example, we're asked to find the measure of an unknown side using the cosine ratio. Well, we'll start by labeling our triangle. And the side we're being asked to find is this one right here, the hypotenuse, which we've labeled x. So we're interested in finding the hypotenuse. We're given the adjacent. So relative to the reference angle, we're looking for adjacent over hypotenuse. So we look over here on the chart and we find the trig ratio that deals with adjacent and hypotenuse, and that just happens to be cosine. We kind of knew that because up here in the question it asks us to use the cosine, but this just kind of confirms it. So we've determined that we're going to use the cosine ratio. We can say that the cosine of 25 equals adjacent over hypotenuse, which in this case, the cosine of 25 equals 18 over x. Cross multiply to solve for x, and we end up with this equation. Cosine of 25 times x equals 18. Using our calculator to find out what the value of cos x is, we can go through those steps again. So type in 25, go to trigonometry, and find out cosine, and I get this value 0.9063, which is where this came from. So now I have an equation, x equals 18 divided by 0.906, and that ends up being a value of 19.86. So we can round that off. Side x is 19.9 centimeters in length. In this example, find the measure of an unknown side using the tangent ratio. So let's start by labeling our sides. We are asked to find the x value, which happens to be opposite our reference angle, and we know the adjacent, which is 12 centimeters right here. We're told to find this using the tangent, so we know that that's going to be our trig ratio, but just to sort of confirm, let's see this. Tangent equals opposite over adjacent. Well, sure enough, we want to find the opposite, and we're given the adjacent, just kind of confirming that that would be the trig ratio that we'd want to use. So we could say that the tan of 49 equals opposite over adjacent. And for this specific triangle, the tan of 49 will equal x over 12. Okay. Solving for x, we can say that x equals 12 times tan of 49. Using our calculator again, type in 49, and it comes out to 1.1503. So we multiply that value by 12, gives us a value for x of 13.8. So that side is 13.8 centimeters in length. In this example, we're asked to find the measure of side AB to 1 decimal place. So here's A, B right here. Since this is the reference angle, this will be opposite, this will be hypotenuse, and this will be adjacent. We want to know the opposite, and we're given the hypotenuse. So looking at our chart, finding the trig ratio that deals with opposite and hypotenuse, we see that we'll be using the sine ratio, trig ratio. So we could say sine 37 equals opposite over hypotenuse. For this specific triangle, sine 37 will equal x over 11. Cross multiply to solve for x. X will equal 11 times sine 37. Going to our calculator, type in 37. Sine gives us a value of 0.6018. So we multiply that value by 11. Gives us a value of 6.6 for x. So that side x is 6.6 centimeters in length. In this example, we're asked to find the length of TS to the nearest tenth. That's 1 decimal place. Here's our reference angle, 22 degrees. So we'll start by labeling our sides. So we're asked to know what side x is, which turns out to be the hypotenuse. So we want to know the hypotenuse. We're given the adjacent. So we look down here to see what trig ratios deals with hypotenuse and adjacent, and we see that that is the cosine. So we know we'll be using the cosine ratio. So we can say that the cosine of 22 equals adjacent over hypotenuse. For this specific triangle, that means that the cosine of 22 will equal x over 9.2. We'll cross multiply to solve for x. That tells us that x will equal 9.2 times the cosine of 22. The cosine of 22 on our calculator tells us that we'll have 9.2 times 0.9271. That gives us a length of 8.5 for x. So side x is 8.5 centimeters in length. In this question, we're asked to find the length of DE to the nearest tenth. So here's DE. Our reference angle is up here. So we'll label the other sides relative to that. Now, we're asked to find the adjacent, and we're told what the opposite is. So looking at our trig ratios, we find a trig ratio that deals with adjacent and opposite, and it happens to be the tangent. So we know that we'll be using the tangent ratio. We can say that tan 9 equals opposite over adjacent. Tan 9 equals 9 over x. Solve for x, cross multiply. Tan 9x equals 9. Isolating x equals 9 divided by tan 9, which happens to be 0.1583. X is 56.8, so our side x is 56.8 centimeters in length.